Okay, guys, so what we're going to do right now is I'm going to go through the chapter 4 portion of the review worksheet and get this kind of set up on here. Hopefully this does not shut off on me like it did at home, and we'll see kind of what we can come up with. So here we go. All right, so we start off with these first two problems that we're solving for x. In the case of both of these, I have got triangles. All three things inside of the triangles are set up with variables. So in both cases, we're going to be using the fact that they add up to 180 degrees to be able to sort of write this out. So as this goes, what I'm going to try to do then is, let's get them going. So I'm going to set this equation up with all three of them together. 3x minus 17 plus x plus 40 plus 2x minus 5 is equal to 180. And in this case, I'm going to set all three of them up as well. 3x plus 28 plus 5x plus 52 plus 2x minus 10 equals 180. Now, guys, I wrote them fast. And the reason I wrote them fast is because I wanted to get them in a place that you could just kind of see them. But you're basically adding all three of the angles together, equaling 180. So we're going to combine like terms and get this stuff going. 3x, 1x, and 2x all together is going to give me 6x. 40 minus 5 minus 17 is going to give me, well, let's think about that for a second. 2, it's going to be plus 18 is equal to 180. If I subtract 18 from both sides, I'm going to get that 6x is equal to 162. And if I divide both sides of this by 6, I'm going to get that x is equal to, let's see, 27 is my answer for this one. That's not one that I have in the top of my head most of the time, but that kind of works. For our next one, we're going to do the same thing. 5x, 3x, and 2x together is going to give me 10x. 28 and 52 together is going to give me 80, and 80 minus 10 is 70. So 10x plus 70 is equal to 180. Subtract that 70 from both sides, and I'm going to get that 10x is equal to 110. And if I divide them both by 10, I get that x is 11. Again, not difficult problems to do, but I wanted you to see the setup and the solution for them. If there's something that you need to go back and look at, please feel free anytime during this video, just pause, rewind, figure out what the setup is. I'm going to try to lead in and explain it and then go to the next thing. But I'm also trying not to make this video, 30 minutes long. So we'll get to as many pieces as we possibly can, as quickly as we can. These next two problems involve, an exterior angle on the outside. And then we have the two remote interior angles on the inside of both these triangles. Now, the rule for this is that the exterior angle is equal to the sum of the remote interior angles. So this plus this is going to equal this. Always the same setup. So that when you're setting them up here, you just need to make sure that you are setting up your equation the right way and solving it. So here, that's going to be 30 plus 4x plus 2 equals 8 plus 6x. So that gives us our first equation. And then for the second one here, 9x minus 2 plus 40 is going to equal 20x plus 5. So we've got the setup where it's the two angles on the inside equal to one angle on the outside. Now we just solve for x. So here I'm going to combine my like terms, and I'm going to get that 4x plus 32 is equal to 6x plus 8. Now I only switch the order for that because it's what I'm used to seeing with the variable first and the number second. You do it however you would like to. Then I'm going to start by taking the 4x off of both sides. And that is going to give me that 32 is equal to 2x plus 8. And if I subtract 8 from both sides, I'm going to get that 2x is equal to 24. Final part about this, you divide them both by 2, and you are going to get that x is equal to 12. All right, one down, one to go here. Same general idea, combine my like terms here. So this would be 9x plus 38 is equal to 20x plus 5. I always move the variables first, and I always pick on the little guy. So I get rid of the little guy first, minus 9x. Minus 9x, that is going to be that 38 is equal to 11x plus 5. If I subtract 5 from both sides here, I'm going to get 33 is equal to 11x. And I always like if we get a double number with an 11 because it divides evenly. Divide them both by 11, that cancels out, and we get that x is equal to 3. Okay, so we're good to go for our equations that we have here. Everything else that we have on this worksheet is now going to be a proof. So I'm going to do my best to kind of talk you through what happens. And if there's something about this that you look at, you're like, what's going on with this? Please rewind and pay attention to the things that I'm saying, because we've got this one here, we got 3 on this side. So I've got to hit them relatively quickly, but you've got the ability to pause, rewind, stop. You probably put me at half speed so I could talk like this. That'd be great too. Okay, so we're talking at the beginning. We're going to put our given information first, regardless, because there's only one statement here. So I'm going to start just by putting that here. C is the midpoint of BD and AE. Since it's the midpoint of 2 things, I want you guys to remember that midpoints lead to congruent segments. So what I'm going to do with this, writing that it's given, I'm going to mark that on our shape first, okay? So the midpoint of BD and AE. Now, I'm not stating these congruent statements, but it helps me. If C is the midpoint of BD, that means that this and this are congruent to each other. If C is the midpoint of AE, that means this and this are congruent to each other. So I have to make those statements, but I also have to look at this and say, this is a bow tie problem. I know that as a part of the bow tie problem, the opposite sides of this are vertical angles, so they are going to be congruent. So if I look, that is a side, an angle, and a side. That's how I'm going to prove this, okay? So right now, I'm just going to kind of pick these one at a time. Next thing I'm going to say is this statement here, that AC is congruent to EC, and that is going to be the definition of midpoint. That's how you go from midpoint to congruence. So that's our first side. Now I'm going to state the angle in the middle. So that is part 3 here. Angle ACB is congruent to angle ECD, and I'll mark those ACB and ECD because they're across the bow tie from each other, which is going to then be our vertical angles are congruent. So there is our A for SA, and then the last one here is going to be our side. And we're going to say that BC is congruent to DC. It's this and this. For the same reason, that definition of midpoint. Okay, so now I've got a side, an angle, and a side. So I can make the statement that triangle ABC is congruent to triangle EDC by the side, angle, side postulate. And I can write 2, 3, and 4. You guys didn't see that. 2, 3, and 4, so that I can show you which steps I have followed. It's pretty straightforward in terms of that one. I like looking at it, knowing that it's a bow tie problem, but that's kind of the place that we're going to need to start to look at that. Okay, we are going to flip over to the back of this page, and we are going to look at problem 4, another hourglass problem. So we know that right now we do have here the vertical angles. We can totally use that. I'm also going to mark what I have given here. I am given that AB is parallel to ED, which in this case is going to give me, I got a bunch of Z's here. I'm going to have alternate interior angles everywhere. And I am told that AB is congruent to ED. So in this case, I can deal with a lot of things. I've got angles and I've got a side. Now I have one side here and one side here. So generally it gets me to thinking I'm either going to have angle, angle, side, or angle, side, angle. Because of the fact that it's parallel to both, I'm going to pause for a minute. Give me a minute. Okay, picking up where we left off. Appreciate your pause there, and I'm going to make sure that when I look back, you guys didn't get to see all of my phone calls. Okay, so when we're looking at this, what I'm going to do is start thinking about what it is that's going to actually be congruent here. Dealing with the parallel lines, I know that if this line is parallel to this line, that means I could have alternate interior angles there, the A and the E. And because it also goes in the other direction, I will also be able to say B and D would be congruent. So if I look at this, I've got angle, side, angle right there already laid out. Perfect. So now what I'm going to do is use that to be able to write this proof. So here's what I'm going to do. I'm going to do this one as a flow chart so you guys kind of see it because I've got it already laid out. So I'm going to do my angle, side, and angle in the middle here. And I'm just going to do kind of the places to write them. So right now, the side here is that AB is congruent to ED. And I know they don't have the lines up there. Some of you guys get grumpy about that. This is okay. That is a given piece of information. So we should be fine with that one. Good. That's our side. Now the two angles are right here, but they both come from the fact that AB is parallel to ED. So let me start with that first. I'm going to write that over here. AB is parallel to ED. That is given. And that then leads to both of my angles. First one that I'm going to say is angle A is congruent to angle E over here. And that's because they are alternate interior angles. They're on the insides of that Z there. So I'm going to go alternate interior angles theorem. And then if I look here, the B and the D are the exact same reason. I can say that angle B is congruent to angle D because of the alternate interior angles theorem. So with that being said, I have an angle side angle, so I can say that triangle BAC is congruent to triangle DEC because of angle side angle. Now, here's the thing. With this one, I didn't use my vertical angles. That's totally fine. Don't have to use my vertical angles for this to be something that'll work, but it's good to know that they're going to be there in a bow tie problem like this. Okay, two more proofs. Okay, anytime that I see perpendicular, I do have to think in my head about potentially hypotenuse leg, but we also know that we have here a shared side triangle. So there's going to be this one in the middle that I'm going to have to say is congruent. So this is what I'm going to do. I'm going to start by saying, well, if I know that these two things are perpendicular, I'm going to mark both of these as right angles. I will have to state that, but that should be okay. And I know that they're congruent to each other. I know now that it says PR and QR are congruent to each other. And I know that I'm going to be able to state that this one in the middle is here. Now, if you look at what we have here, this is angle side side. Not allowed to do an ass triangle right now, are we? But it is a right angle. Because that's a right angle, this means I have a hypotenuse. And this means that this is a leg. So I'm going to use hypotenuse leg to prove that this triangle is congruent. It's going to take a minute. We haven't done a whole lot of these. So I want to make sure that you kind of follow through how I start this. And it's going to go like this. I'm going to start just with the given information that I have here with the perpendicular. Because what you want to do if you're going to use hypotenuse leg is you want to establish that you have right angles so you can say that they are right triangles. So I'm going to go with given for this piece of information. And from that, I'm going to say that angle 1 and angle 2 are right angles. Now, the general idea is you go from perpendicular to right angles, and then you're either dealing with the fact that it's a right triangle or you're going to say that they're congruent. I have to state that they're right angles, and that always follows from the definition of perpendicular lines. So I can just say definition of perpendicular and I'm good to go. Now, I know that they're right angles. So I know that that is a right triangle. The next thing I'm going to do is my given piece of information. That is that PR is congruent to QR, and that's given. Once I've stated that one, we know that this is the hypotenuse because it's opposite the right angles. I'm going to put an H over here next to it. Then, because I know it's a right angle, it's already a right triangle, and that's established. The next thing that I can state is that RS is congruent to itself. My reason for anything being congruent to itself is the reflexive property of congruence. And because that is just one of the sides, that is going to be our L or our leg for this right triangle. If I have a hypotenuse and I have a leg, I can then state that the two triangles are congruent to each other, that PRS is congruent to triangle QRS by hypotenuse leg, and that is 3. Okay, we haven't done a lot of those, but that's the way that you would set something like that up if you were going to do a proof for that one. Now, problem 6 is its own special brand of hell. So let's see if we can kind of look at this and figure it all out. Right now, we got this solid straight line here. Fair enough. We know that AB is perpendicular to BC, so I'm going to mark that. You know, the DE is perpendicular to EF. I'm going to mark that. I know that BC is parallel to FE, and I know that AB is congruent to DE. Now, they're not saying anything about AC and FD, so this one is not going to be hypotenuse leg. I'm going to have to say that those angles are congruent to each other because they're right angles. It's totally fine. but I'm missing something here with the parallel lines. I've got a side and I've got an angle. So I'm going to need another angle someplace or another side. In this case, because I'm looking at these two parallel lines, the only connector between those two parallel lines is this line here, which means I'm going to have alternate interior angles right there and right there. This would be angle, angle, side to be able to figure that part of it out. Now, this one's got a lot going on, okay? So what I'm going to do, I'm going to try to write as much of this down as I can, but we're going to try to put it together so we can get that angle, angle, side portion, okay? And that's the order, angle, angle, side. So here we go. First thing that I'm going to get, why don't I even just do it this way? I'll do angle, I'll do an angle, I'll do a side. Now that first angle that we have there that I'm going to be stating is this one and this one. So that's going to be angle BCA is congruent to angle EFD. Now we look at that, it's going to be alternate interior angles theorem, but I need to go from that first to know that those two lines are congruent to each other. So that's where that angle comes from, or not congruent, but parallel. That BC is parallel to FE, and that is given. Now, I worked backwards with that to go from parallel to alternate interior angles. I knew I needed that, but you see how one dovetails into the other, and you need to do the given before you can do the alternate interior angles. So right now, check, check. The next angle, gonna take a second. And in fact, this is going to be a two-step process. So what I'm gonna do is this. The two angles that I'm gonna state are congruent are gonna be B and E. So I'm gonna tell you that angle B is congruent to angle E because they're both right angles, right? So this is going to be right angle congruence theorem. It's that all right angles are congruent. Now, the thing that I need to say before this is that angle B and angle E are both right angles. All right, let's make that statement. Angle B and angle E are right angles. Now I have to think about where I know that from. I know it because of perpendicular things. Okay, so this is going to be definition perpendicular, but I have to state that they're perpendicular first, right? So I'm going to put that down here, that AB is perpendicular to BC and DE is perpendicular to EF. Those are the statements that allow me to say those are right angles. And this right here is given information. All right, so let's follow through with that. Perpendicular ones are given. Two angles are right angles by the definition of perpendicular. Then those angles are congruent to each other by the right angle congruence theorem. So it's a solid 1, 2, 3. It's kind of harder to follow when you're looking at it as a flow chart, but man, there's a lot of stuff going on with this problem. So I want to make sure you see it all. So we have this angle here. We have this angle here. The other great thing about the side is all I got to do is state the given. AB congruent to DE, that is given. And thankfully, I can say, hey, guess what, guys? These two triangles have to be congruent by angle, angle, side. ABC congruent to triangle DEF by angle, angle, side. Okay, that is the sum total of everything that we have here on this page. And it should be enough to kind of give you an idea as to what we're going to be looking at. If you have any questions, please be sure to ask them on Monday. And I'm happy to come back in and explain that to you. But that should be enough for us to figure all of this out.